Alright, so welcome to video 1.2. We're going to talk about function characteristics here. There's a lot of definitions here, so make sure to pause it on the definition screen and then copy down what it says. Alright, our first two definitions are positive and negative. We're looking at the y values here, the y values, where if it's positive, if I'm saying the graph is positive, the y values are greater than 0. If you're staring at a graph, that means we are above the x-axis. Negative, the y values are less than 0, and looking at a graph, the y values are below the axis. All right, pause this, copy that down. All right, so if we have a graph example here, so if I asked you, where is the graph positive? Look at your notes. We said that positive is where the y values are greater than 0, or if we're looking at a graph where we are above the x-axis. So where is this graph above the x-axis? Right there. So we are above the x-axis where I highlighted yellow. So that would be positive. If I asked you where the x-axis is negative, then we would look at where it is below the x-axis, where the y values are negative, and we're negative there and there. So the red is where our graph is negative because we are below the x-axis. The yellow is where our graph is positive because we are above the x-axis. Okay. It is very easy to mix up positive and increasing. So make sure that you copy these down and or pay attention to what you're writing. Okay, so increasing is where the y values are increasing as the x values are increasing. That's the proper definition. An easier way to think about it is when you're looking at the graph from left to right, just reading it like normal, the graph looks like we're running uphill. Decreasing is the opposite. Increasing is where it looks like we're running uphill. Decreasing is where it looks like we're running downhill. If we go back to the graph that we just looked at, if I'm asking you where the graph is increasing, where it's increasing, that's where if I'm reading left to right, where does it look like the graph, if I was walking, if you put your fingers on the graph and we were walking on the graph, where would we be walking uphill? Well, if we start right here, because that's the first point on the graph, and I follow the graph, did my yellow line just go up or downhill? It went uphill. So, since it went uphill, that would be increasing. If we start right here where I pick my pin up and follow the graph, on that part of the graph, we just ran downhill or went down a slide, however you want to think about it. Since we ran downhill, the red line would be increasing. So the red part, oh, sorry, I just messed up. It's decreasing. The red part here is decreasing because we're running downhill. The yellow part is increasing because we're running uphill. All right. I know this is a ton of definitions. I'm sorry that this is your first video for homework, but just get these down. So there's two different types of minimums and two different types of maximums. There's an absolute, I'm only going to talk in depth about minimum, but the absolute minimum, if you read what I have in parentheses, absolutely nothing is lower than this point. If you think about a valley, there is a definite lowest point of that valley. That would be our absolute minimum. You can't go lower than the bottom. A local minimum, it's just going to take an example for me to really explain that better. But it's the lowest point, but on a defined interval. So if I tell you only look between the x values of 0 and 5, what's the minimum between those 2 points? So we'll have an example. Absolute max is the same thing as absolute minimum. Absolute max is like a mountain over the whole graph, though. We look at the whole graph. And the absolute max means there is no y value higher than that point. And local, same thing. I'll show you an example. All right, so I'm going to label some different things on this graph to try to help you get the gist of what's what. So the first thing I'll do is the absolute minimum. So the absolute minimum is the absolute lowest point over this whole crazy looking graph. Looks like we're hanging Christmas lights or something. So the absolute lowest point on this graph is right here. So since that is the definite lowest point, that is our absolute min. I'm not going to write minimum, but it's the absolute minimum. Sometimes you'll see global minimum too, but I'm just going to use absolute. So since that's the lowest point, that is our absolute minimum. Change colors. If you look, though, we have another little dip, another little bottom here. So that's not the lowest point on our graph, but it is where we have a little valley, another little dip. So since there is a little local valley, this is the local min. We don't always have local. But when you're thinking about local, if you think about like, large towns or something, big cities, some cities are bigger than other if you think about where you are on a map. So this absolute min is the definite lowest point. There's nothing lower than that. But if you look at the left and we're only looking right around this little green dot or green highlighted, that is the lowest point in this little area right here. So we're going to call that a local min because it is the lowest on this little part of the graph. This may be confusing at first, but hopefully with more practice it makes more sense. Again, we don't have to be experts just because we watch one video. All right, now we'll do absolute maximum. So our absolute max is the highest point on the graph. Nothing is higher than that point, and that would be up here because this is the definite highest point on the graph. Nothing goes up higher than that. So this is our absolute max. And our local max is just like local min, where it is maybe not the highest point on the whole graph, but if we only look right around it, it's the highest point in its little area. So if we're looking for mountains on our graph, we have one right there. That would be the highest point in this little middle area. So we're going to call this purple point the local max. All right, and sometimes we can have a ton of local, sometimes we won't have any local. It just depends. Last slide, I promise. This is it. Our last definitions, and this is really just one definition. So we have the words zeros, x-intercepts, and roots. Those are interchangeable. The word zero, the word x-intercept, the word root, those all mean exactly the same thing. These points mean where on the graph does it cross the x-axis. If we're thinking about it algebraically, this is if we plug in 0 everywhere we see an x, what do we get for y? So if you plug in 0 for x, if you plug in 0 for y, what x values do we get? I said that wrong. So when we plug in 0 for y, what x values give me 0 for y? So the word zeros comes from, we can find these by plugging in 0 for y. The word x-intercept comes from the point where the graph crosses the x-axis. And the word roots is just a math term that you'll see a lot in college. So I don't really know where that comes from. So if we were trying to identify the roots or zeros or x-intercepts, whatever word you want to use, on this graph we have one there, and one there, because it's just where do we cross the x-axis? So that is at negative 4, 0. This one is at 0, 0. And this one is at 4, 0. So if you notice, the word 0 comes from the y value of all three of those points is 0. And x-intercept we know because I highlighted the points where the x-axis intercepted the graph, or where the graph touches the x-axis. All right, so there's video 1.2.